Welcome to a lesson on cylindrical coordinates. In this video we'll take a look at defining cylindrical coordinates and also how to convert between cylindrical and rectangular coordinates. In a cylindrical coordinate system, a point P in space is represented by the ordered triple r, theta, and z. R theta is the polar representation of a point in the xy plane, where r is a directed distance from the origin in the xy plane, and theta is the angle counterclockwise from the pole or positive x-axis in the xy plane. And z is the directed distance up or down from r theta in the xy plane. So this might be a little bit small, but if we consider the location of point P in space, r would be the distance from the origin or pole in the xy plane. Theta would be the angle of rotation from the positive x-axis or polar axis, which would bring us to here, and then the z-coordinate would tell us whether to go up or down. Let's take a look at an animation that illustrates this a little bit better. As we increase r, we're moving along the positive x-axis or polar axis. As we increase theta, we rotate counterclockwise from the polar axis or positive x-axis, as we see here. And as we increase or decrease z, we will either move up or down. And here you can see why it's called the cylindrical coordinate system. Any point could be viewed as on a cylinder. And here's a location of that point in space. Using some trigonometry, we can come up with these equations that relate cylindrical and rectangular coordinates. We have x equals r cosine theta, y equals r sine theta, z is equal to z. And we also have r squared equals x squared plus y squared, tangent theta equals y over x, and again z equals z. So let's take a look at doing some of these conversions. Here we want to convert the point 113 to cylindrical coordinates. And in this problem they do want us to express the point in two different ways. So we're given x, y, z, and we need to determine r, theta, and z. Let's start by determining r. R squared is equal to x squared plus y squared, so here we'd have 1 squared plus 1 squared. So we have r squared equals 2. Take the square root of both sides. Remember, in polar coordinates, r can be positive or negative, but for our first point, let's go ahead and use the positive value of r, so we'll let r equal the square root of 2. So for our polar coordinates, we can use r as the square root of 2. Remember, z is equal to z, so we know the z-coordinate would be 3. And now we need to determine the value of theta, and we can use the second equation here where tangent theta is equal to y over x. So tangent theta is going to be equal to 1 over 1. This should remind us of a 45, 45, 90 right triangle. Remember, there's an infinite number of angles that have a tangent function value of 1. We'll go ahead and use the most obvious one, where theta would have to be 45 degrees or pi over 4 radians. So this would be one way to express this point in cylindrical coordinates. But remember, it does ask us to express this using two different ways. So going back to what we know about polar coordinates, if we change the sign of r using a negative value of r, we'd have to plot an angle that would be different than pi over 4. So if we add 180 degrees or pi radians to this, it would be the same location in the xy plane if we're using a negative value of r. Remember, when r is negative, you plot the point in the opposite direction. So here we could use 5 pi over 4 radians instead of pi over 4 radians. And then of course z would be the same value. So there's two ways to express the point 113 using cylindrical coordinates. In this example, we want to convert the cylindrical coordinates of 4 pi over 3 negative 2 to rectangular coordinates. Here's the location of that point plotted in cylindrical coordinates. We go out 4 units from the pole, rotate pi over 3 radians, and then down 2 units. So for rectangular coordinates, we want to determine x, y, and z given r, theta, and z. So the x coordinate is going to be equal to r times cosine theta. Well, that'll be 4 times the cosine of pi over 3 radians. Just to refresh our memory, that would be a 60-degree angle. So using the 30, 60, 90 right triangle, here's our 60-degree angle. The cosine of 60 degrees, or pi over 3 radians, would be 1/2. So we have 4 times 1/2, which would give us 2 for the x coordinate. The y coordinate is going to be equal to r sine theta. So we're going to have 4 times the sine of pi over 3 radians. So we're going to have 4 times the sine of pi over 3 would be square root 3 over 2. Well, this simplifies here, so we have 2 square root 3. And that's all we need, because remember that z is equal to z. So the rectangular coordinates for this point would be 2 square root 3, and -2 for the z coordinate. Now, one last thing I want to mention about cylindrical coordinates. We will talk about cylindrical equations in the next video, but there are some surfaces that are very convenient to represent using cylindrical equations. Here we have r equals 3, which creates a circular cylinder. R equals z would be a cone. R equals the square root of z would be a paraboloid. And theta equals pi over 4 would be a plane, as we see here. So we'll talk more about cylindrical equations in another video. I hope you found this video helpful. Thank you for watching.